With more multiplication properties of exponents, we're going to look at exactly that, even more multiplication properties. There's so many of them that we decided to split them up into 2 separate lessons. Specifically in this one, we're going to be simplifying expressions using the power to power and the product to power rules. So first, let's look at expanding a power of a power. It looks something like this: 2 to the 3rd power, and then that power is raised to the 4th power. The power of 4 that's outside of those parentheses, outside those brackets, it tells us to multiply out what is contained inside the brackets 4 times. So expanded out, it looks like this: 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times 2 to the 3rd. I have 4 of those powers being multiplied together. And having that expanded out, I can use what we learned last lesson where you add the exponents for multiplication. So 3 plus 3 plus 3 plus 3 is 12. Hopefully you see the shortcut there, that 3 and 4 are related because they have a product of 12. So our conclusion is that when a power is raised to a power, just like this, you multiply the exponents. So let's practice a little bit with this. P to the 5th power and that to the 3rd power. What is meaning when that's being expanded out is P to the 5th times P to the 5th times P to the 5th power. And we know when you're multiplying powers with the same base, you add their exponents and you get P to the 15th power. Ideally, this step right here is done in your head. Or if you have forgotten the rule, you expand it out and it reminds you, oh yeah, I'm essentially multiplying 5 times 3. And you go directly from that to your answer of P to the 15th power. So something like this, P to the 1/2 power to the 3/4 power, you are multiplying those exponents. And you'll remember from multiplying fractions that you just multiply straight across. So that would be P to the 1 times 3 on top, 2 times 4 on bottom, the 3/8 power. So simplified would be P to the 3/8 power. Now let's deal with algebraic expression. Same principle, yet we have variables as bases. You still are using order of operations when you're dealing with exponent and with powers. So within those exponents, you're doing the order of operations. This exponent of the -4th power is being applied to x to the 6th power. So I'm going to multiply those powers together because it is a power to a power. So I have x squared times x to the 6 times -4, which would be x to the -24th power. Now since I have powers with the same base, I'm going to add their exponents of 2 and -24. So I have x to the -22nd power. And going back to what we learned in the first lesson, a negative exponent causes that power to go to the denominator of a fraction. You're taking the reciprocal of it. So simplified to its barest form would be 1 over x to the 22nd power. Let's look at our other example over here. S to the -5th to the -1/2 power times s to the 3/2 power. I'm going to start with that exponent in there. And yeah, I know with the order of operations you start with parentheses, but there's nothing to be done inside those parentheses, so that's where I'm going to the exponent, and then I work my way in. That -1/2 is being applied to s to the -5th power. Since it's a power to a power, I multiply their exponent. So think of that as 5 over 1, and when you multiply -5 over 1 and -1/2, you get s to the 5/2 power. And bring down the second part of it, s to the 3/2 power. Here I have multiplying powers with the same base, so I'm going to add those exponents. Lucky us, they already have a common denominator of 2, so I'm going to add their numerators, which are 8. So I have s to the 8/2, and that 8/2 can be reduced to the whole number 4. So simplified down would be s to the 4th power. Let's look at our second rule, expanding a product rule. So what's different about what we just saw is here I have 2 factors inside the parentheses. That m is being applied to each factor inside that. So that m is distributed almost to the a and to the b. The power outside the brackets, which was the m, it needs to be applied to all of the bases, a and b, inside the brackets. So this is like the distributive law, the distributive property, but it's with exponents. It's very similar to that. Here's another example of how that would play out. That 2 is put on the a and to the 2 base. So that's 2 squared times a squared. 2 squared can be simplified down to 4, and so 4 times a squared would be 4a squared. The 2 and the a both need to be raised to a 2. So concluding for this, when a product, meaning there's something being multiplied inside the parentheses, is raised to a power, you apply that exponent to each factor inside the parentheses like you do with a distributive property. Let's practice here. That 3, let's make that a little better, get a different color. That 3 is going to be applied to the m to the 9th and to the 7. So I have 7 to the 3rd power, and then m to the 9 to the 3rd, so that's going to be multiplied to be the 27th power. If you were to go ahead and expand 7 to the 3rd power, let's get a calculator. Calculator. There's one. Okay. So 7 times 7 times 7 is 343. So I have 343 times m to the 27th power. Okay, now let's come to this one over here. That negative 2 power is going to be applied to the 2 and to the z. So I have 2 to the negative 2nd power times z, I'm going to put a line through it so it looks like a z and not a 2, to the negative 2nd power. That negative exponent is going to shove each of those powers to the denominator. So I would put a 1 on top. I have 2 squared and then z squared. And 2 squared can be simplified to 4 z squared. There is my simplified version. Now let's put it all together here. That square is going to be applied to that, and there's only one factor inside there, so I could just go ahead and multiply those exponents and have x to the negative 4th power. Then for my second set of parentheses, that 4 is applied to y to the 5th, to x, and to 3. So 3 to the 4th power, well, I know 3 squared is 9, so times 3 would be 27, times another 3 would be 81, and then that would be x to the 4th. And y to the 5th to the 4th power would be y to the 20th power. Then I need to combine my common bases there. So x to the negative 4th and x to the 4th power. Negative 4 plus 4 is 0, so I have x to the 0 power, which I know is 1. And so that 1 is essentially going to cancel out because 1 times 81 will be 81. So those canceled, so I have 81 y to the 20th power. Let's look over here at this one. That 4 is going to be applied to each factor in there, and that's a multiplication sign, not a variable in there. Think of this as like scientific notation. 3 times 10 to the 8th power, and then that is being raised to the 4th power. That's why there's an x inside there instead of a dot, because it's representing scientific notation. 3 to the 4th power times 10 to the 32nd power. So we're trying to keep this as scientific notation. 3, actually that shouldn't be a 4th power, should it? I'm sorry, a square, that should be to the 4th power. Maybe you caught that before I did. Good for you if you did. 3 to the 4th power is 81. 81 times 10 to the 32nd power. That first factor in scientific notation has to be between 1 and 10, so I need to move that decimal over 1, and so what that does is it raises the 10 power to the 33rd power to accommodate that decimal move.